In this subject, we will have special function, integral of some functions that have their own integrals. After we finish this topic, we will learn how to make the integral for some special function. And let's go to see more details. So, here we will look at some functions that have their own integral. And from the most famous function, this function, trigonometric function, natural logarithm function, logarithm function with the base a, exponential function with the base e, and the last one, exponential function with the non-base e. Okay, so let's see the first one, trigonometric function. As we can see here, this is the integration, and here the derivation for this trigonometric function. The derivation for the sine, it will be cosine. Cosine, the derivation for it will be minus sine x, and the derivation for the tan x, it will be sec to the power 2, and the derivation for cotan, it will be minus cosec to the power 2. Anyway, this one, the derivation, you should memorize it. You should memorize this derivation like your name, and remember, the differentiation is the reverse process of integration. Once you know how the derivative for the function, it will be easy to make the integration because it will be the opposite. There are some of the most important mathematical relationships between trigonometric functions. For simplification, this important formula that we need to memorize, because it will help us to simplify the function in case we need it. As we can see, tan to equal sine divided by cosine, cotan equal cosine divided by sine, and tan to be 1 divided by cotan, and sec will be equal 1 divided by cosine, and cosec will be equal 1 divided by sine. This is also important. Let's see example. Find the derivative of the following function. Before we go to solve this one, let's see these notes. The important note in differentiation for the trigonometric function is that we do not forget to multiply by the angle derivative of the trigonometric function. Meaning, as you can see, the derivative of the sine, it will be cosine, and we will multiply the function x to the power 5. We will take the derivative, it will be 5x to the power 4. Same situation here, the derivative of tan, it will be sec to the power 2. And the term of x, we will keep it as it is, and we will multiply for the derivative of this one. It will be 6 and x to the power 5 plus 3 after taking the derivative of the angle of the trigonometric function. Simple. See another example. Find the integral of the following function. Here we have another note, important note. We multiply by the inverse coefficient of the derivative angle of the trigonometric function. Let's see. The integral of cosine for x, it will be sine for x, and we will multiply by the inverse coefficient of the derivative angle. What is the derivative of this one? It is 4. We will multiply in the inverse coefficient. So it will be 1 divided by 4. So the result, final result, it will be 1 divided by 4 plus the constant numbers. Let's see another example. The integral for this function. First, we will try to arrange the integral function in simple way. So we will see integral cosec multiply 1 divided by sine x dx. This one, it will be cosec. So the integral will become integral cosec multiply cosec. So it will be cosec square. And the integral for this one, as we know from the previous formula for the integrals, it would be minus cotan x plus constant number c. Let's see the other one. The integral of sine divided by tan multiply cosine. It will be the integral sine, we'll keep it as it is. Tan, it is sine divided by cosine. We will keep the cosine as it is. After the simplification, we'll get x plus the constant number c. So this is what we have today, and see you next lecture.